ADS79XX analog to digital converters. Welcome to this training module on the ADS79XX ADC family. This training module provides an overview of the ADS79XX ADC family and introduces their key features and applications. Successive approximation register SAR converters are frequently the architecture of choice for medium resolution applications with medium sampling rates. They provide low power consumption and have a small form factor. In more recent designs, the topology of SAR AD converters uses a capacitive redistribution design approach instead of its predecessor architecture, the R2R ladder topology. With the topology shown in the figure, the analog input voltage is initially sampled by connecting the input signal to the bottom side of sampling capacitors. This configuration is achieved with the sampling switch S sub S. The other ends of these sampling capacitors are connected to the reference voltage. Now that the input signal has been sampled, the bottom side of the MSB capacitor is connected to the reference voltage, while the other capacitors are tied to the system ground. With this action, the charge from the MSB capacitor is distributed among the other capacitors. The comparator input moves up or down in voltage according to the way the charge is distributed. If the voltage across the capacitive array is greater than the comparator reference, an MSB equal to 0 is generated, and the MSB capacitor is left tied to V sub ref. If this voltage is less than the comparator reference, an MSB bit equal to 1 is generated, and the MSB capacitor is connected to ground. The ADS79XX is a 12-10 8-bit multi-channel analog to digital converter family. The devices include a capacitor-based SAR analog to digital converter with inherent sample and hold. The devices accept a wide analog supply range from 2.7 volts to 5.25 volts. A wide 1.7 volt to 5.25 volt I/O supply range facilitates a glueless interface with the most commonly used CMOS digital hosts. The serial interface is for easy connection with microprocessors and DSPs. The devices offer an attractive power down feature. This is extremely useful for power saving when the device is operated at lower conversion speeds. Very low power consumption makes these devices suitable for battery-powered and isolated power supply applications. There are 2 software selectable input ranges, 4 individually configurable GPIOs, and 2 programmable alarm levels per channel. These features make these devices suitable for most data acquisition applications. The table above lists all 12 devices from this product family. The ADS79XX device family offers 16, 12, 8, and 4-channel multiplexers for analog input. The multiplexer output is available on the MXO pin. AINP is the ADC input pin. Device operation is controlled with CS, SCLK, and SDI. The device outputs its data on SDO. Each frame begins with the falling edge of CS. With the falling edge of CS, the input signal from the selected channel is sampled and the conversion process is initiated. The device has 4 general-purpose input-output GPIO pins. These 4 pins can be individually programmed as GPO or GPI. GPO data can be written into the device through the SDI line, and similarly, the device outputs GPI data on the SDO line. The device also has 2 programmable alarm thresholds per channel. If the input crosses these limits, the device flags out an alarm on GPIO 0 and GPIO 1 depending on the GPIO programmer register settings. The ADS79XX can operate with an external 2.5 volt plus or minus 10 millivolt reference. A clean, low-noise, well-decoupled reference voltage on the REF pin is required to ensure good performance of the When the converter samples an input, the voltage difference between AINP and AGND is captured on the internal capacitor array. The peak input current through the analog inputs depends on a number of factors: sample rate, input voltage, and source impedance. The current into the ADS79XX charges the internal capacitor array during the sample period. After this capacitance has been fully charged, there is no further input current. When the converter goes into hold mode, the input impedance is greater than 1 gigaohm. To maintain linearity of the converter, the CH0 to CH-end and AINP inputs should be within the limit specified. Outside of these ranges, converter linearity may not meet specification. There are three modes for channel sequencing, namely manual mode, auto 1 mode, and auto 2 mode. Mode selection is done by writing into the control register. A mode control register is configured to operate the device in one of three channel sequencing modes. The program registers are used for device configuration settings and are typically programmed once on power-up or after device reset. There are different program registers such as Auto 1 mode programming for pre-programming the channel sequence, Auto 2 mode programming for selection of the last channel in the sequence. On power-up or after reset, the default channel is channel 0 and the device is in manual mode. The device power-up sequence is shown in the figure. Manual mode is the default power-up channel sequencing mode, and channel 0 is the first channel by default. These devices offer program registers to configure user-programmable features like GPIO, alarm, and to pre-program the channel sequence for auto modes. At power-up or on reset, these registers are set to the default. It is recommended to program these registers on power-up or after reset. Once configured, the device is ready to use in any of the three channel sequencing modes, namely manual, auto 1, and auto 2. There are two alarm program registers per channel, one for setting the high alarm threshold and the other for setting the low alarm threshold. For ease of programming, two alarm programming registers per channel, corresponding to 4 consecutive channels, are assembled into one group with a maximum of 8 registers. Each alarm group requires 9 CS frames for programming their respective alarm thresholds. In the first frame, the device enters the programming sequence, and in each subsequent frame it programs one of the registers from the group. The device offers a feature to program less than 8 registers in one programming sequence. The device exits the alarm threshold programming sequence in the next frame after it encounters the first exit alarm program bit high. The device has 4 general-purpose input and output GPIO pins. Each of the 4 pins can be independently programmed as general-purpose output, GPO, or general-purpose input, GPI. It is also possible to use the GPIOs for some pre-assigned functions. The device refreshes the GPIO data on every CS falling edge as per the SDI data written in the previous frame. Similarly, the device latches GPI status on the CS falling edge and outputs it on SDO if GPI is read enabled by writing DI04 equal 1 during the previous frame in the same frame starting on the CS falling edge. Typically, it is convenient to short MXO to the AINP pin so that signal input to each multiplexer channel can be processed independently. The signal inputs from the sensors. In this condition, it is recommended to limit source impedance to 50 ohms or less. Higher source impedance may affect the signal settling time after a multiplexer channel change. This condition can affect linearity and total harmonic distortion. Another option is to add a common ADC driver buffer between the MXO and AINP pins. This relaxes the restriction on source impedance to a large extent. The typical characteristics show that the device has respectable performance with up to 1 kiloohm source impedance. This topology, including a common ADC driver, is useful when all channel signals are within the acceptable range of the ADC. In this case, the user can save on signal conditioning circuit for each channel.